As always, I've developed a SQL script that generates the same results as this section. When you sum up the %dp time column in the top 10 foreground events by total wait time section, you get 100.6%. Approximately 100%. This makes sense. However, in the wait classes by total wait time section, the sum of the %dp time column is 122.2%. Where does the extra 21.6% come from? The extra 21.6% arises because the former section only accounts for foreground events, whereas the latter encompasses all events across the entire instance, including the background events. The primary contributor to this discrepancy is the system I/O wait class, but it's not the sole cause. This can be further supported by the time model statistics section. Background elapsed time divided by dp time is approximately 22%. Let's examine the leftmost columns of the wait classes by total wait time section. Average active sessions. This column can be interpreted as follows. On average, at every second, 20.6 sessions are engaged in user I/O. 9.1 sessions are using CPUs. Compare this with the number of CPUs on your server to assess CPU utilization. 8.3 sessions are performing system I/O, combined with 20.6 user I/O. Total I/O reaches 28.9. This number can be cross-checked with the number of disk spindles in your system, etc. In total, there are 48 active sessions, including both foreground and background sessions. This figure can be correlated with the dp time per second from the load profile section, which is 39.2. Here's how it breaks down. Subtracting the dp time per second 39.2 from the total active sessions 48 leaves 8.8, which represents the number of background sessions. The percentage of background sessions relative to the total dp time is calculated as 8.8 divided by 39.2, which is approximately 22%. This aligns with our earlier calculation from the time model statistics.